my super smart biologists. Good to see you're back. It's going to be another adventurous ride today because we are going to look into how a biologist thinks and makes his amazing discoveries. Well, for starters, you need to adopt the biological method. As you have already seen, science follows a systemized flow of knowledge. And just like any scientific branch, biology also requires an experimental inquiry and has a set methodology. The general rule is simply that any scientific observation or discovery needs to be tested first. Once it's tested and confirmed, it is released out as a theory or becomes a scientific law. So, what do you think could be the starting point of any biological discovery? It's pretty simple. It always starts with an observation. Let me tell you a story. Once upon a time, there was a famous scientist, Newton. He was sitting under a tree thinking about the forces of nature. Suddenly, an apple fell from the tree, and that chance observation led to the discovery of Newton's law of gravity. This indicates that our 5 major senses, namely vision, hearing, smell, taste, and touch, play a primary role in making an observation. Observation could be either qualitative or quantitative. Quantitative observations can be measured in numeric values and are considered more accurate because they show an exact number. Now, once these observations are collected, biologists organize them into data and produce a statement called a hypothesis. I know you all must be wondering what it means. Well, a hypothesis is a statement that reflects the data based on the experience of the observer and the background knowledge of an event. But this is not a confirmed statement. It's only a tentative explanation of a biologist's observations, which means that it needs to be tested. But before jumping onto the method of testing, let's see how a biologist writes a hypothesis. It's pretty simple to follow and is done in 2 different ways: deductive reasoning and inductive reasoning. Now, deductive reasoning moves from a general to a specific statement. Let me explain with an example here. So, a deductive reasoning statement would look like this. If all monkeys like bananas and Lucy is a monkey, then Lucy likes bananas. What I did here was to use a general principle or any original assumption to draw a specific conclusion. And did you see? This type of reasoning also follows the if-then clause. Now, let's bring in a specific example from biology. Let's say if all birds have wings and all sparrows are birds, then we can conclude that all sparrows have wings. That was a piece of cake, isn't it? Want another example? Say, if all green plants need sunlight for photosynthesis and photosynthesis results in the production of glucose, then any green plant that is placed in the dark will not synthesize glucose. All these examples show deductive reasoning. Now, let's take a quick break before we move on to inductive reasoning.